So I see lots of computers. That's good. Continue to bring your laptops for the remainder of the semester. There will be a handful of class meetings where we don't use it, but by far the majority of the classes you will need to have a computer. And then homework number 3, which is on your to-do list right now, should be uploaded to Blackboard by Wednesday at noon. So any questions about the announcements? Okay. Let's review what we talked about last time about balance. What we had was an example where there was an outflow of $60,000, and because you'd made some investment at time 0, you were expecting to receive revenues at the end of each year for 5 years in the amount of $8,000. So in that illustration, what you did was move the money from the future to the present. And there's a certain word that I've used a few times to describe that process of moving money from the future backwards in time. Does anybody remember what's the opposite of compounding? Discounting, right. Compounding is when you're moving money forward in time and it's earning interest and the amount is getting larger. Discounting is when you're moving money backwards in time and the value is decreasing. So in this illustration, what we did was we discounted the annual series to time 0 and found out what is the equivalent amount as a lump sum. So economic equivalence between either having a series of payments in the future or a lump sum at the present for a given interest rate. We wanted to find out what interest rate makes it so that $60,000 in the present is equal to 5 annual payments of $8,000 each. So that's the one where we went through and we found it was between, I think, 10 and 11%. It was maybe 10.425% was the interest rate that caused it to be in balance. So balance between inflows and outflows allows us to calculate what we'll learn later on is the rate of return for a project. So the process of doing that, discount future amounts to the present, combine it with amounts that already are at the present. So in our example, we knew that there was an outflow of $60,000, and that arrow down means that we spent $60,000, and this arrow being up means that the current present value of these future revenues is some quantity. And what we were solving for is what is the interest rate that made it so that the revenues discounted to time 0 is equal to the cost, which was already at time 0. So just to review, if you're still feeling confused about that concept, I'd recommend that you spend some time in the textbook and potentially review the recorded lecture from Wednesday. Now we're going to talk about how we can use spreadsheets to really streamline how quickly we can go through calculations. It saves us loads and loads of time, and you should be really grateful that you're taking this class now and not 30 or 40 years ago before spreadsheet tools were more common. So we can calculate the present value of some future amounts by using the PV function in Excel. It's built into Excel. So the PV function, once you type equals PV and then the parentheses, it's going to automatically prompt you with these words rate, NPER, PMT, FV, and type. So rate is a prompt just to let you know that when you're putting numbers into the equation, you should enter in the interest rate that's applicable. Anybody remember what NPER stood for in the illustration last time? It's the number of periods. And so if we have annual compounding, then that would be the number of years. If we have monthly compounding, that would be the number of months that applies in the problem. PMT means payment. And what you should put into that field would be a constant annual series. If the amounts are changing over time, then you should avoid putting a quantity into the payment field, and instead I'll show you how we put those changing quantities into the future value field. The fact that future value is in brackets means that that's an optional quantity that the built-in function PV can be executed with just potentially the first 3 fields being filled in. It doesn't necessarily have to have an FV or the type defined. Type is where you're telling Excel whether it's the end of period assumption, which is the default, and so if you leave it blank, it'll automatically assume the end of period assumption, or if for some reason you needed to change that assumption to the beginning of period assumption. Okay, so just as another way of showing what goes in, equals PV, then a parentheses, you enter the interest rate as a decimal, enter the number of periods, and then most of the time what we're going to do is put in 2 commas, because we're going to want to skip over the payment field. In all but just a few rare cases, we'll put the quantities that we're having it calculate in the FV field. And what about this minus sign? Anybody remember what that's about?
Like our default language is that you would just make an error.
Yeah, Excel by default assumes that if you put a positive amount into the future value, then it should tell you a negative amount for the present value. It's always changing the sign on financial calculations. And so most of the time we'll override that by manually putting in the minus sign. So interest rate is a decimal, very important. N is the number of periods, oftentimes years. Double comma to skip over the payment field most of the time, and I'll illustrate to you why we do that. Because if you put numbers into the payment field, it assumes it's going to be repeated n times. And most of the time we're using the PV function on sequential rows where each row represents a different year. And of course, Excel assumes that sign change. All right, so let's do a quick demonstration here of how to use the PV function to calculate the present value. So what I've got is an annual series where each payment that you're going to receive is $8,000 a year for 5 years. The discount rate is 10%, and we want to find out what's the present value of that. So let me go to Excel. You can just watch this, but if you want to follow along by creating your own spreadsheet, of course you can. So equals PV, and then a parentheses. Let me make it even bigger because I think that text is probably pretty small. Okay. Equals PV, parentheses, and now down below that, it's prompting for the rate. So it's just a reminder. So should I type in 10?
No.
No. What should I type in?
0.1.
Good. So 0.1, comma. Now when I type the comma, now it's bolding NPER. So the number of periods. So I'm going to put in the number 5 because there are 5 of these inflows over time that I'm discounting to the present. Now another comma, and it says, what is the amount of the payment? Now this is one of the rare times that I'm going to put a number into that field, and I'm doing it just because I want to illustrate how it works. So I'm going to type in 8,000, but there's one more thing I need to do. I need to put a negative sign in front of that because of the sign change that it does. Okay, so with those 3 fields defined, what it's going to do when I type enter, is it's automatically going to calculate the present value of this annual series. 30,000, 360, 326, and 29 cents. Okay? Now, usually I'm not going to want to type numbers directly into the function because what if I want to change the interest rate? It would be tedious to go in and manually edit the function. So let me show you, most of the time what we'll do is we'll have some sort of a field where we type in the interest rate like just as a number, so 0.1, and here I could have like for example n equals, and here I'll put the number 5, the annual series is equal to 8,000, and then here I'll say PV, and then equals PV. All right, now I'm going to just click on the location. Rather than typing the amount in like I did a moment ago, I'll click in the location where it says the rate. So I click on where it says 0.1, and you'll notice it says B4 below that. Okay, now a comma, I'm going to click where the number 5 is written. And so it just replaces where I've clicked with B5, which is the column and row reference for that cell. And finally, minus of the amount, And so it's going to calculate that same 30,326, but now the advantage of having it as references rather than the numbers in the formula is if I wanted to change the interest rate, then everything dynamically is going to update. So if I changed it to 11% interest and then type enter, then the present value automatically updates. I can just adjust things around, and it's better and more useful than if I had the numbers hard-coded into the function. All right, so that is how you'd use the PMT field. But most of the time, we're going to, instead of doing that, want to put the amounts into the future value field. And I'll explain why in a moment, but let me just show you how. Okay, so I'm going to have the interest rate defined, 0.1, and then I'm going to have year, amount, and PV of amount. Okay, so the year 0, 1, 2, 3. Now, rather than typing all the years, once you have a trend, highlight the cells, and if you click and drag downward, it'll continue the trend. So you don't have to type everything. If you've got, the numbers are just increasing by 1, then just again how I did that was I highlight 2 of them and then continue to drag down until I get to 5. That's just a small shortcut that may save you a little bit of time. Okay, so the amount that's at the present is 0, at the beginning. Then we've got 8,000, which repeats through the 5 years. And so instead of typing it in, again, I've just drugged by grabbing the lower right-hand corner of that cell, dragging it downwards. It just continues the same amount. Okay, so now I'm going to use the PV of amount function. So equals PV, the rate. I'll click on the cell that has the rate. Now this time I have to push the F4 button, because if I don't, when I drag the formula down, it would always be looking at a different cell. So by putting in dollar signs before the B and the 22, what I'm telling Excel is always look here for the interest rate. That's called an absolute reference. Okay, so I've absolutely locked the interest rate to that cell. Now for the NPER, that should be the year that we're in, if it's doing the PV function. Now I'm going to do the double comma, so comma, comma, and then minus of the amount. So here's what my first PV is 0 because there was no money being discounted. But as I drag it down, you'll find out that, for example, if you're moving $8,000 backwards in time for only 1 year, then the discounted value of that is $72.72. This is the $8,000 that's here in year 2. If you have to move it back 2 years in time, its value at time 0 is going to be even smaller. So by the time we get to year 5, this $8,000 in year 5 is only worth $49.67 because it's been discounted every year that we move it backwards through time. So then the total, we have to do a sum now. So the sum of, I'm going to click on the shift button as I scroll upwards with the arrow key so that I'm selecting a range. So it's going to be the sum of C25, oops, I clicked in the wrong spot, equals sum of this, 30,326. So we got the same answer here that we did here when it was 0.1%, 0.1 for the interest rate, meaning 10%. You may be wondering, well, why do this more complicated method? Like, why put every number on its own row? And the reason why is because oftentimes we're going to have cash flow diagrams where the amount isn't the same every year. You'll have the amount small, then large, then reduced, then maybe nothing, then large again. So that second method would allow you to solve this problem and this problem. You could solve both, equal amounts every year or different amounts every year, by using the approach of this table. But if you don't do the table, if you just try to put the amounts into the payment field and the amounts are changing every year, you're going to get the wrong answer. So it's better to solve problems according to that table method that I've just illustrated. So are there any questions about that? Okay, there's a function called net present value. It's a built-in function that I want to demonstrate how you use it. So if we had these amounts over time, and we want to find out what's the present value of it, I'm going to show you how to use the NPV function. So equals NPV parentheses. Now it gives us the same prompts, little reminders of what it needs to know. So it says, tell me the rate. Okay, so I'll click in this location. I can lock it or not lock it. It doesn't matter because I'm not going to be applying the NPV function to successive rows. So that's why I'm not going to lock the reference there. Okay, now with the comma, it's going to ask for values. So it wants to know what are the amounts in terms of the quantity in the year that it appears. So it's not asking for the discounted amount. It's actually asking for the actual amount that is experienced in the future. So I'm only highlighting the amounts that are in the future. I'm not highlighting that zero at time 0. So highlighting the amounts that are in the future, and then close parentheses, NPV, 30,000, 326 and 29 cents. That's the same. Look what would happen if I had accidentally highlighted everything. NPV, okay, interest rate 10%. Now, if the range includes an amount that's in time 0, it's going to tell me the wrong thing because it's going to think that that first cell that it sees is in year 1. Notice I did not highlight the years. It's just automatically knowing that whatever is the first quantity it sees is at the end of the first period. But I've done the wrong thing. And if you do the wrong thing, then you get the wrong amount. So the rule is only put future amounts into the NPV function. All right, so in the slide here, I reiterate that same advice. Only include future values in the NPV function. So you put in the interest rate as a decimal, then highlight a range of values which are in the future, and then it will calculate the present value. And by net, what it means is you could include outflows and inflows into the NPV function. And it'll find the cumulative value after having discounted them all to the present. So any questions about NPV function? All right, I know you're eager to get your hands dirty with this, so let me hand out the in-class exercise. Here's a cash flow diagram, and you should set it up like I did here. There should be a column that is year, there should be a column that is amount, and the amount column is just you translating the cash flow diagram to a table. And then here in the PV of amount column is where you should use the PV equation to calculate the present value. Now the interest rate here it says is 7%, so have a location above the table where you are defining the interest rate. So let me hand this in-class exercise paper to you now. If there are extras, as always, please pass them back. I think I can't on the fly get all the amounts just right. You got one? Any more needed? Any stumbling blocks along the way, that'll help clarify. So I'm just going to paste the cash flow diagram over here. Okay, so I want to have up at the top I equals, and then the number itself should be in a different cell. If it's in the same cell as the I, I'm going to get an error message. So 0.07. So only a number is in this cell that I'm going to be looking to for the interest rate. Let me make that a little bit bigger so that hopefully you can see better. Okay, so now I'm going to have year, amount, and PV of amount. So I need to translate the cash flow diagram to a cash flow table. And there's 16 years, so I'm going to drag this down so that I've got 16. Okay, so amount, 0, 0, 12, 500. Now I don't have to type 12,500 4 times. I can just drag it down through the 5th year. Then 0, 0, now 15,000. And I can drag that down through 4 years. And then 0 for year 12, 17,000, negative 7,000, 0, and 8,000. Okay, so I translated the cash flow table, cash flow diagram into a cash flow table. Now comes the tricky part. This is really important. So equals PV for the rate. I'm going to click here, and I need to put the dollar signs in. Otherwise, if I don't, when I drag the formula down, it's going to be looking at the next cell down, then the next cell down. And so it won't be referencing the correct interest rate. So I can just press the F4 button on my keyboard, and it'll automatically put those dollar signs in, or you can just type them in. So $B, $1. Okay, so now comma. It says it wants the number of periods. I'm just going to click on the year that I'm in, because what that means is it's asking how many years are you discounting it from the future to the present. So any amount that's in year 0 to begin with should move 0 years. But when I drag it down and it's looking at row 1, then it would say it's going to discount whatever amount is in the first year, 1 year, to get it to year 0. Okay, so that's why I'm clicking on the year for NPER. Now I'm going to do double comma to skip over the payment field, and minus of the amount in the future value field. And then close parentheses, and that's that. Okay, so I'll drag it down. And see how this is red and has the parentheses by it? That's the formatting, kind of like in an accounting style, which I don't particularly like. So I always just manually tell it to apply the style of currency, and then it puts a minus sign there instead. Now the last thing I need to do is add everything up. So the sum equals sum, and then I click all of the cells, and here is the present value of this cash flow diagram over time. Okay, so does anybody have questions of a certain step that I did that you need to see another time?
Yeah, last step being
Sum?
Yeah.
Yes. Okay, so what you do is you just equals sum, parentheses, and then I'm using the mouse by highlighting the top of the list, and I'm clicking and holding the left mouse button while I drag down, and you'll notice that what it is creating is a range. C4 colon C20 means all of the numbers in between C4 and inclusive of C20. All right, so let me pause the recording and I'll circulate around. And, you know, this is something that requires practice. There's no reason to expect that you'd instantly be really proficient at this. if you're still struggling, my recommendation is go through the video after class and do this a couple of times until it becomes very smooth how to lock the cell reference, how to enter in the formula, and so on. All right, that was calculating the present value. If you need to calculate the future value, there's a built-in function that's called FV. Can you guys please be quiet? Guys? Thanks. The future value function, you put in the same information into the fields. There's the interest rate, the number of periods, and then you'll once again need to skip over the payment field when we set these up row by row, each row representing another year. So the big difference in this kind of a function is that n isn't the number of years that you're on, it's the number of years until the future date. So in problems like this, what we're going to do is create a secondary time column. So for example, if we had this cash flow diagram, this is our in-class exercise for the next problem, we want to find the future amount, we wouldn't put 0 for year 10, for this $10,000 at year 0. Like, it doesn't need to move 0 years to get here to 16. It needs to move 16 years to get to the future. So, for example, this 11,500 that's in year 2, it doesn't move 2 years to get to the future. It needs to move 14 years to get to the future. So we'll set up a spreadsheet that has different columns than the one that we've had in the previous example. So let me just illustrate how to set this up. I'll show you a template on the screen, then I'll pause from talking so that you can work on this one as well. I equals, we define the interest rate in this problem. What's the interest rate? 8.5%, 0.085. Okay, now we've got years until year 16. I need to make this a little bit wider. Amount, and then FV of amount. Okay, so there's going to be year 0, 1, 2, and so on, all the way through 16. And then for years until year 16, so the amount that's at time 0 has to be compounded 16 years into the future. So you could just type it 16, 15, 14, and continue the trend down to the end like that. Or you could do 16 minus whatever year that you're on, and it gives you the same effect. Now, rather than dragging, see, you could, drag it. You could also double click, and it'll just take it to the end of the row that's adjacent to the left of it. See that green box at the lower right? Instead of clicking and dragging on it, I'll just double click, and it fills the formula down through the rest of the rows. All right, so now we have to translate the cash flow diagram into a cash flow table. You can do the same as I type it in, 10,000. It's easiest to see if you've typed it incorrectly if the commas are there. So I recommend that you format it as currency. And so like if you just type in 1,000, sometimes you may not notice that you're missing a 0 that's needed for 10,000. I just got a good question about the homework. So if you use Excel for your homework, you should create a different tab for each problem. That's the best way to do it. Now, the homework that you need to submit next week has some hand calculations and some Excel problems. So what you should do is do your hand calculations on paper, but then also write the final answer on paper when you've done your calculations in Excel, and upload both. Upload both the PDF and the Excel file. All right. I'm going to illustrate how to calculate the future value. So let's assume that you've correctly translated the cash flow diagram into a cash flow table. Now, by default, it may have coloring or parentheses. I like to have the currency formatting, and then just to make it so that it's a little bit less cluttered, I decrease decimal to only show the dollars rather than also the cents. That's a matter of preference. Okay, so future value equals FV. Now, I'll click on the rate and press the F4 button on my keyboard to automatically add those dollar signs. So we've got the anchored cell reference to the interest rate, comma, NPER. Okay, so we've got $10,000. Does it move 0 years to get over here to 16, or does it move 16 years to get to 16? Yeah, it moves 16 years. So I'm going to click on this reference rather than on year 0, because if I click on year 0, it's going to compound that 0 years into the future. I want it to compound 16 years. Okay, so then double comma to skip over the payment field, because I'm treating this $10,000 as an individual isolated amount that's going to be compounded into the future. It's not recurring 16 times. If I put the amount into the payment field, it assumes that there are 16 payments of $10,000. And that's not the case. So that's why I put the double comma in there to skip over the payment field, and I have the negative of the amount. Okay, so once I get that amount in, I can just double click and it applies the same formula through the entire rows, total it, and the correct answer should be $3,821. Or if you've got all the cents showing, $3,820.67. Let me show you one more important tip before you go. If I have the interest rate label and quantity in this cell, so if I have I equals 0.085, it's not going to calculate. It needs just the number. It can't read the letter or the labeling. It can only read the number. So 0.085. So separate the label. That's in a different column than the quantity, which represents the interest rate. Okay, remember, this video will be on YouTube, and you should practice this. You need more reps. You need more practice to be able to get it. The homework assignment is very closely related to this, so I think it should be natural once you get the in-class exercise figured out. Have a good weekend.